Our Locomotive Division, Locomotive Service Manual, Part 6B, Revision A, Section 6B, Part B, Electrical Transmission. General restriction in the diesel electrical locomotive and the mechanical power to develop the diesel engine converted with electrical power, the rotating electrical machine with the construct of the rotating electrical generator such for the alternating current is produced with the sense of the alternating current that will not efficiently power variable supply motor of the alternating current must be converted with the direct current within the traction purpose. The conventional alternating current is converted with the direct current mean with the communicator bar with the brushes. System has electrical limitations become critical become more and more power that's developed and larger and improved with the diesel engine. In 1966, the model turbo locomotive equipped with the model 645 engine with the conventional direct current with the generator that had been replaced with the AR10 alternator that has been silicone diodes to do the job of the communicator bar with the brush. Figure 6B, 62, 6Bs 1, 6B2, and 6B3 show the three major components that make up the AR10 alternator. The AR10 alternator assembly consists of the two mechanical couples of electrically independent DC excited with the air-cooled three-phase alternator, the traction alternator, companion alternator. The traction alternator consists of the 10 field poles with the required with the stator, the winding with the generator, three-phase AC power. The AC power is rectified with the two banks air-cooled silicone DI that are an integral part of the AR10 assembly, with the result of the DC power U with the locomotive with the traction. The companion alternator is familiar with the D14 with the U with the excitation of the traction alternator, the power of the AC motor driven the current with the current cooling fan, the dust evacuated power, and the certain excitation control device. For the excitation of the D14 alternator is taking the auxiliary DC generator that provides the power for the battery charging switching gear operation for the control of the person. 6B1 shows the AR10 rotary assembly, 6B2 shows the AR10 stator assembly, and 6B3 shows the AR10 rectifier bank assembly. Or the traction alternator. 6B14 and 6B4 illustrate for the operating principle of the traction alternator direct current with the silicone control with the rectifier assembly passing through the alternator slit the ring for the armature pole winding with magnetic flux with developing the pole cut with the stator winding with the rotor turns. The current of the stator windings are connected with the term of the Y manner with the directly with the power rectifier bank with the waveform showing with the three-phase AC with the up one group with the stator with the winding with the shown with the gear 6B with the alternator wound conventional manner but will rotate counterclockwise and locomotive thereby for the phase for the ABAC. Alright, 6B4 is the alternator pictorial diagram. Look at the 360 electrical degrees of the three-phase three AC waveforms. A, B, and C going backwards, or C, A, and B with a stator winding symbol A, B, and C, which were stator winding grouped repeatedly 10 times around the stator in 360 degrees. Computation spike expressors, three resistors, rectifiers, and DC power, positive, negative rectifier, magnetic flux, south pole, and now south pole. Rotor containing 10-fold peels, rotation slip rings, DC field supply from controlled rectifier. The stator windings arranged approximately shown in figure 6B4 with repeated with a 10-time circle with the stator with five of the winding groups are connected with the bank of the rectifier with the other five that are connected with the second bank. Each of the bank rectifiers contained with a separate power with the negative buses. 6B5 the schematic illustrates the alternating stator winding with the rectifier bridge for the DC buses. Alright, one's in the middle you have your parallel blocking repeated A-phase rectifiers. You see the three windings of 1A, B, and C, 2A, B, and C, and then going down 3, 4, 5, 6, 7, 8, and 9, 10 poles. Feedback signal at the bottom of the out of your on the opposite out on the line of feedback on the line to the field back signal. Also in between the bus poles, you have a shading 5 match diodes in a group. Fuses, blowout indicators repeated at each phase. Also on the other side, you see a fuse equipped with blowout indicators repeated at each phase. You're between the bus bars and poles, negative shading indication 5 match diodes in a group. Alright, figure 6B illustrates for the rotor pole for the position at the instant call for the V pole with the position with respect with a single stator of the winding group apply with the right hand with the rule for the generated current flow with the stator winding with the can be determined with the condition existing with the given the point of the time determined. Note that the phase A winding is centered over the pole with the point over the greatest flux density is at the negative potential. Note that also the potential for the phase C decreasing with the potential phase B increase at the moment of the expected potential C and B are equal to positive. There must be a current with the equal flows potential flow of the rectifier bridge of the two diode with the positive side of the bridge conduct. Total current with the flow through the load and through their wire through the single diode with the phase A winding, which is the negative potential. General potential can be observed with the waveform of the part with figure 6B6. Alright, rotation, point of time, up and down, alternating rectifier, Between A and B and C, is C and A, you have B, and B and A and C. And this 6 or B, C, 6B, 6 and through 6B10 cover the 120 electrical degrees alternator rotors movements as indicated in the shaded area. You have A, B, and C, 3 windings, north, south, and both, and bus loadings on the and 10-pole field contactors, 3-way winding A, B, C, 2 diodes conducted simultaneously in sync with the phase of the C and B intersect. In figure 6b7, the instant W with the alternator rotor has turned with a normal 20 electrical degrees phase A, the still negative with both decreasing potential. The phase B is more positive than phase C, but the change of the potential has been turned with the phase C diode with now current flows in the phase C winding. Total current potential slightly greater than the instant V now flows to the phase B winding through the load and back to the phase A winding is still negative. Potential at the point A, B, and C, and then B, and then A. And then you have the 3-wheel winding C, B, A, B, and C showing and the rectifier positions, which make one circuit, which hold one of the 2 of the windings together for actual to cut the circuit in half. Bus bar rectifiers. An instant X of the figure 6B, 8 with the alternator rotor with the 60 electrical degrees, phase C with the phase A with the L equal negative potential, the phase B with the positive potential, the current flow with the C winding has reversed some of the since potential for the negative side of the rectifier bridge are equal to both sides by phase A and phase C. Diodes conduct. The total winding current with the potential equal with the instant V now with the flow for the phase B winding with the load with the back through the 2 diode with the negative side of the rectifier. Alright, you have your 2 diodes conducting simultaneously at instance phase A and C, and then B conducting back to the load to the bus before it goes back through the rectifier. Alright, instant Y, figure VB 6B9 with the alternator rotor. It has about 100 electrical degrees with the phase C with the more negative phase with the A with the chain with the potential to turn off of the phase A. Now the negative side of the bridge, no current flow for the phase A. Winding 2 current potential slightly greater than the instant V and outflow to the phase B, winding through the load of the neck phase for the C winding, which is negative. So you have condition at any given time. The C going, B is going directly through the bus load and back to C. In figure 6b10, the alternator rotor has turned 128 degrees. Place A and B are equal to the positive potential, and phase C negative is the potential for the positive side rectifier bridge with the equal to the phase A with the B diodes inducted. Total winding current potential equal to the instant V now with the load for the AB winding through the load back through the phase C and diode with the negative side of the bridge. Potential at the point of time, CBA, also on the bottom stroke you would have CBA condition given the point of the time, which was shown in the little electronic diagram as both A and B going through rectifiers to the bus bar and then to the last rectifier back to C. Alright, communication. Since sim waves are upper proportion of the 6B411 that indicate the point at which the communication occurred with the chain with the potential crowd with the gave and the diode with turn with the diode with the turn off the out, turn not off the out over the immediate wave seen with the indicate with a short period of the time called the recovery time that required with the complete turn off of the diode. During the period inverse the voltage of the diode reaches the high value and the inverse voltage and is exceeded with the rating of the diode may be destroyed. The 2 lower waveforms of 6B11 illustrate the condition with the given diode during the communication period that A lasts a few microseconds after the circuit voltage is reversed. During the period with the diode junction of the sweep of the cleaning with the charge of the much of the capacitor will be the reverse current flow. The current during the period is determined by the circuit circuit EMF, electric motor force, and circuit impedance, which is like stale electrodes in one point area until it like holds the resistance. Alright, reverse current during the series second period. B, continue with the chain with the diode sweep apart with the rate of the switch with the charge sweep apart with the transient voltage with the transient voltage will multiply with the circuit induces. Give the inverse voltage of the diode. The application capacitor resistance as shown in figure 6B4 with the 6B5 reduce the inverse voltage at the diodes to prevent stressing of the diodes. Figure 6B11 show the rectifier current voltage and waveform during communication. Points of communication are in the dips of the sim waves on both sides of the AC and DC voltage, inverse and inverse. You have your inverse voltage rating of the diode, the volts and forward and reverse, and inverse the forward and reverse and forward on the top, and then the peak of the reverse located the leak of the voltage, computation spike, peak of the inverse obtained with the application communication suppression capacitor and resistor, and then you have B, you have peak inverse without suppression. That was, once again, this was Electric Motive Service Manual Part 6B, Section Electric Motive Division. This applies to the GB40, 7040, 7040, 70P40, and 7045.